We know that climate change is going to have massive impacts on every aspect of this planet. In this video, we will explore some of the impacts that climate change is having and is expected to have on biodiversity in order to better understand what needs to be considered in conservation. Climate change is going to have an impact on every ecosystem on the planet and by proxy on every species. Increasing temperatures, more frequent and more intense storms, and rising sea levels are among the effects of climate change that will have the most significant impacts on biodiversity. Some of the possible consequences of these effects include species declines and even extinctions, behavioral changes within ecosystems, an increased prevalence of invasive species, ocean acidification, and increased occurrences of natural disasters like fires. This graphic is from a paper led by Alnit Arnath from the Karlsruhe Institute of Technology in Germany, and it outlines some of the future impacts on a number of different ecosystems that are likely to occur because of climate change in the future. Climate change will also cause changes in seasonal patterns, such as earlier springs and later winters, which will alter phenology, things like leaf out and flowering times, as well as migrations and breeding patterns. There is a rapidly growing body of evidence to suggest that there are widespread and pervasive impacts of climate change on many aspects of biodiversity, such as habitat loss and fragmentation, and some models suggest that climate change will outpace the significance of any other driver of biodiversity loss in the near future, as in by the end of the century. As we discussed in the last video, there is a strong relationship between climate and where a species can live. Climate change will mean that the suitable areas for a particular species will shift, in general moving north or upslope. Because of the tight relationship between climate and the ability for a species to persist, species will need to move with their preferred climate as climate change progresses. This process is called a range shift. Many species are shifting their distributions poleward or to higher elevations in response to climate change, though there is huge variation in the rates at which the range boundaries for a particular species is moving. The variation is caused by a number of different factors, including differences in climate sensitivity, resource requirements, reproductive rates, and phenotypic plasticity. Of course, not all species will be able to move along with their preferred climate, which is a major threat of extinction. One conservation strategy for species which are unable to make the necessary migrations is assisted migration. Assisted migration, which is also sometimes called assisted colonization, is a specific type of long-distance species introduction which aims to establish a new population of a species in an area that it does not currently exist in. The key with assisted migration is that the destination habitat is predicted to have the species' preferred climatic conditions at some point in the future. The goal is to move a species from a threatening environment where it is not expected to be able to survive over the long term and give them a second chance in a new area that is likely to be more favorable to their long-term survival. In the context of climate change, assisted migration is thought to possibly be a useful strategy for species with poor or limited dispersal abilities, particularly plants. It is also a drastic option and not one that has been employed on any large scales. It is also a controversial option, as it goes against the aversion to introduce species that is prevalent among conservationists. But some people feel that it may be their only option for ensuring the persistence of some species, as some argue that even perfectly connected corridors of habitat will be insufficient for some species, given the rates of climate change that are projected for the coming decades. As species move around, either on their own or through the actions of people in assisted migrations, they will likely end up organizing themselves into new communities, creating new, novel ecosystems. As a reminder, novel ecosystems are characterized by non-historical species configurations that arise due to anthropogenic environmental change, land use changes, species invasions, or some combination of all three. They are a consequence of human activity, but they do not depend on human intervention for their maintenance. As we discussed a few weeks ago, new and novel ecosystems present a challenge to conservation, which has a tendency, at least historically, to want to favor the conservation of familiar communities and ecosystems. However, climate change may force conservationists in this camp of the discipline to abandon these preferences, as these historical ecosystems may simply not be able to persist. When thinking about the impacts of climate change on biodiversity and conservation, an important concept to keep in mind is extinction debt. Extinction debt refers to the disappearance of a species due to events in the past. It occurs because of the time delays between impacts on a species, like the loss or fragmentation of habitat, and the species' ultimate disappearance. For example, a long-lived tree may survive for many years, even decades after it becomes unable to reproduce, but because it can't reproduce, the species has been committed to extinction. We can think about extinction debt on local, regional, or even global scales, but most examples of the phenomenon in the literature are local, simply because it's easier to observe and model extinction debt on finer scales. Most examples of extinction debt are also of long-lived species and species with very specific habitat requirements. Extinction debt is caused by many of the same drivers as extinction in general, the most prominent of which is habitat loss and fragmentation, which causes extinction debt by reducing the ability of a species to persist through the limiting of immigration to new habitats. Pollution may also cause extinction debt by reducing a species' birth rate or increasing its death rate, resulting in a population that slowly declines. They may also be caused by an invasive species or by climate change, where a species is unable to shift alongside its preferred conditions, leaving a few remnant individuals that will ultimately be the last of their kind. Extinction debt may also be caused by the loss of a mutualistic species. For example, in New Zealand, the extinction of several species of pollinating birds has created an extinction debt for the shrub species that rely on them for reproduction. As the plant is long-lived, it still persists, but as it is unable to reproduce, its fate as a future extinct species has really been sealed. Extinction debt has a number of implications for conservation, as it implies that even if habitat loss and fragmentation is halted, species are still likely to become extinct, and that the protection of existing habitats may not be enough to protect some species. However, with restoration efforts, it may be possible to eliminate or at least delay some extinction debts. Overall, climate change will impact biodiversity in every corner of the Earth, driving changes in species ranges, community composition, and physiology, which will not only enhance the existing pressures on biodiversity, but will create new challenges for conservation.